Good day. In this video, we are going to learn how to interpret speedtime graph and describe the movement based on the graph. In a speedtime graph, the vertical axis represents the speed of a motion in meter per second. The horizontal axis represents the time taken in seconds. Speedtime graph show how the speed of a moving object changes with time. Using data from the graph, we can calculate the rate of change of speed, that is, the gradient of the speedtime graph. We can also use graph to calculate distance traveled. The area under a speedtime graph represents the distance traveled. For its unit, the rate of change of speed is measured in meter per second square or kilometer per hour square. Make sure the unit for time used in the speed is the same as the unit for time. Meter per second in speed and second in time. Kilometer per hour in speed and hour in time. Now, let's get a bit more in depth in a speedtime graph. Here's a graph showing a relation between speed and time of a moving object. The diagram below shows a motion from P to S in a period of 6 seconds. Let's study segment by segment. The line PQ is in upslope, shows the speed of the object increase. The gradient of graph is positive, hence the rate of change of speed is positive. The rate of change of speed is defined as acceleration. Acceleration can be calculated by change of speed divided by change in time. The distance traveled is represented by the area under the line PQ in the first 2 seconds. Object continue moving from Q to R. QR is a flat line which parallel to the time axis. Zero gradient means that there is no change of speed. The object moves at a constant speed. The distance traveled is represented by the area under the line QR from second to third second. The last segment, RS. RS is in downslope, show the speed of the object is decreasing. The gradient of graph is negative, hence the rate of change of speed is negative. In this case, the rate of change of speed is defined as deceleration. Deceleration also can be calculated by the change of speed divided by change in time. There is no change in the direction, that is, the motion of the object remains the same direction. The distance traveled is represented by the area under the line RS in the last 3 seconds. Now we try to calculate the rate of change of speed for the first 2 seconds. We can see the change of speed is 30 meters per second and the change in time is 2 seconds. Find the rate of change of speed. The line is in upslope. The rate of change of speed is defined as acceleration. We divide speed by time. 30 divided by 2 equals 15. The object accelerates at a rate of 15 meters per second square for the first 2 seconds. QR is a flat line with zero gradient, means that there is no change of speed. The acceleration becomes zero. Hence, the speed remains constant throughout the line QR. The object moves at a uniform speed of 40 meters per second for the periods of 1 second. Last, calculate the rate of change of speed for the last 3 seconds. We can see the line is in downslope. The speed is in decreasing. Hence, the rate of change of speed is defined as deceleration. Deceleration equals to change of speed divided by change in time. The change of speed is 40 meters per second and the change in time is 3 seconds. 40 divided by 3 equals to 13.3. We have a deceleration of 13.3 meters per second square in the last 3 seconds. Then, we can also use graph to calculate total distance traveled. The distance traveled is always the area under the graph. To find the distance, we divide the graph into trapezium, rectangle, and triangle. Find the area and add them. Find the area of trapezium. Area of trapezium equals to 1/2 times sum of parallel sides times distance between them. Its parallel side 10 and 40 with a distance between the parallel lines of 2. That is 1/2 times 10 plus 40 in the bracket times 2 equals to 50. Area of trapezium is 50. Next, find the area of rectangle. Area of rectangle equals to length times breadth. With the length of 40 and the breadth of 1, 40 times 1 equals 40. Area of rectangle is 40. Last, find the area of triangle. Area of triangle equals to 1/2 times base times height. With the base of 3 and height of 40, 3 times 40 divided by 2 equals to 60. Area of triangle is 60. Here, the total distance traveled can be found by adding up the area of the graph. 50 plus 40 plus 60 equals 150. The entire distance that the object covers is 150 meters. Let's try the examples of the Speedtime graph. The Speedtime graph shows the motion of one Fiona's car for periods of 15 seconds. A. Calculate the rate of change of speed in meter per second square for the first 5 seconds. Looks at the part in the first 5 seconds. The line is in absolute, hence the rate of change of speed is defined as acceleration. Acceleration equals to the change of speed divided by the change in time. We can see the change of speed is 20 and the change in time is 5 seconds. 20 divided by 5 equals to 4. The rising slope says that the speed is increasing, so one Fiona's car accelerates at the rate of 4 meters per second square for the first 5 seconds. B. Describe the motion of the car for the second 5 seconds. The second 5 seconds fell on the 5th seconds till the 10th seconds. The motion in this period is inconstant. That is, the car moves at a constant speed of 40 meters per second for the periods of 5 seconds. C. Calculate the total distance in meters traveled in the periods of 15 seconds. In a Speedtime graph, the distance traveled is always the area under the graph. To find the distance, we divide the graph into trapezium, rectangle, and trapezium again. Then, find the area and add them. Firstly, the area of trapezium. Area of trapezium equals to 1/2 times sum of parallel sides times distance between them. Its parallel side 20 and 40 with a distance between the parallel lines of 5. That is 1/2 times 20 plus 40 in the bracket times 5. The calculated result is 150. Area of trapezium equals to 150. Then, find the area of rectangle. Area of rectangle equals to length times breadth. With the length of 40 and breadth of 5, 40 times 5 equals 200. Area of rectangle equals to 200. And the trapezium again. Its parallel side 40 and 60 with a distance between the parallel lines of 5. That is 1/2 times 40 plus 60 in a bracket times 5. The calculated result is 250. Area of trapezium equals to 250. Add the areas together to find the total distance traveled. 150 plus 200 plus 250 equals 600. One Fiona has traveled 600 meters in the periods of 15 seconds. The next example, Mr. Daniel drives his car to a convenience store to buy newspaper. The Speedtime graphs show the motion of the car from his house to the route junction before reaching his destination. A. Describe the motion of Mr. Daniel's car for the first 10 seconds. The first 10 seconds show a rising slope, implying that the speed is increasing. Hence, the rate of change of speed is defined as acceleration. The change of speed divides the change in time. We can see the change of speed is 25 meters per second and the change in time is 10 seconds. 25 divided by 10 equals to 2.5. The car accelerates at the rate of 2.5 meters per second square for the first 10 seconds. D. What happens to the motion of Mr. Daniel's car from the 10 seconds till the 20 seconds? The 10 seconds till the 20 seconds is in the flat portion. Zero gradient implies that Mr. Daniel's car moved at a constant speed of 25 meters per second from the 10 seconds till the 20 seconds. C. Calculate the rate of change of speed in meters per second square for the last 5 seconds. From the graph, look at the last 5 seconds. The line is in downslope, negative gradient. This shows that the speed is in decreasing. Since the speed in the last 5 seconds is not known, and the gradients on the straight line are the same. Therefore, the rate of change of speed can be determined by the speed in the last 15 seconds. The rate of change of speed for the last 5 seconds equals to the rate of change of speed for the last 15 seconds. Hence, the rate of change of speed is defined as decelerations. We can see the change of speed is 25 meters per second and the change in time is 15 seconds. To calculate the deceleration, we divide speed by time. 25 divided by 15 equals 1.66. Daniel's car has a deceleration of 1.66 meters per second square in the last 5 seconds. D. Calculate the distance in meters traveled during deceleration and describe the motion of the car for the period. The distance traveled during deceleration is the distance traveled in the last 15 seconds. As previous, we know the distance traveled equals to the area under the graph. The periods for distance traveled during deceleration fell in the last 15 seconds. Form a triangle in shape. Find the area of the triangle. Area of triangle equals to 1/2 times base times height, with the base of 15 and height of 25. 15 times 25 divided by 2 equals 187.5. The car travels for 187.5 meters in 15 seconds with a deceleration of 1.66 meters per second square. That's all. Thanks and see you.